I wasn't sure how to run this because I like to do interactive classes, and that's what I've done in the past in these master classes. And I found myself wanting to do kind of a machine learning example, but that's really what I did at the last hackathon. So I went through a logistic regression model, and if you want to see that, I'm going to talk about that a little bit more sort of halfway through. So I've concentrated really on just trying to answer some of these basic questions about, have you ever wondered what data science is? You know, can I do it? How do I do it? The classic, what's the difference between a data scientist and an analyst? Is there really a difference? And so hopefully these people here in the audience have come across these questions, and that's exactly why you're here. So I've got quite a few things to cover, but we should be able to race through so you can get back to the challenges relatively quickly. But we're going to go all the way from what is data science, what do you need to succeed, all the way through to the last few slides are about kind of my methodology of how I approach data science problems and actually tackle them and start to solve them. So, what is data science? And I spent a lot of time writing this slide, thinking about how to encapsulate what I think data science is in a single paragraph. So I think the problem is when you try and describe to somebody who's not ever had anything to do with data science what it is, it's difficult because it is a blend of different things. It's about mathematics, it's about statistics, it's about algorithms, it's about coding, and it's about analysis. So I think Hemant Sharma actually has this really nice quote. Data science is a blend of various tools, algorithms and machine learning principles, with the goal to discover hidden patterns from raw data. And I think that encapsulates data science really well. So if anybody asks you that question, you can just memorize that and just reel that off. Okay, and what do you need to succeed? And I think the first thing to stress with this slide is that I'm not saying this is what you need to succeed professionally in data science. I think I'm trying to say the opposite of that, actually. This is like an introduction slide introducing me and how I've ended up in this kind of role, but I don't think that this is the really important thing to succeed in data science nowadays, and especially how the kind of market and the industry is going. I think it's moving further and further away from this, yeah, I have a PhD in machine learning or maths or stats or computer science, and it's looking actually more at the next slide. So I do have a PhD in applied maths. I think these slides are distributed, so you can go and read my thesis if you really want. It's linked. I also spent a couple of years lecturing in mathematics at the University of Kent, and I joined Projecting Success just over a couple of years ago, making that transition from academia into industry. And then last year I became Neo4j certified, which is a graph database, and I passed all of the exams to do that. So I think this is actually the more important slide about your interests, and all the people that I've interviewed for data science roles over the last couple of years. I think it's the box ticking exercise of your kind of professional qualifications. I think really right now that's looking at things like, have you got a quantitative degree? It's not about having a PhD or a master's. I think the qualifications side of things are becoming more flexible, and it's all of the extracurricular things, the things you're interested in, your own projects, the thing that really set you apart from other candidates now. So I have a genuine interest in mathematics, so I still pursue bits of mathematics. This is the fifth Panelet equation you can see on the right hand side, which I spent a lot of time studying. I have a genuine interest in machine learning and analytics, so I spend my own time looking at new models that are coming out and trying to apply them to different bits of my own personal life as well. And I am genuinely interested, and I think this is really, really important, even though it kind of moves away from data science and analytics as such. But I am, as a person, obsessed with computers and technology. I'm always looking at the latest bit of tech and wanting it, and I think that goes hand in hand with data science. So if you're interested in things like Raspberry Pis, making your own projects. I think that does all feed into all of the data engineering and everything that also goes with data science. So I think that's really important. And in looking at somebody's CV, they can write all the right things, but as soon as you sit down in front of them and say, so tell me about the projects you've been working on, you can very quickly get a good understanding if somebody's invested in analytics, machine learning, predictive analytics, much quicker than you can from, like I said, the kind of box ticking, yes, you've got a degree in some quantitative field. So applications with data science at the moment, they are absolutely everywhere. So it's absolutely exploding. It's in social media, in sentiment analysis, automation. We've all heard of Google's self-driving cars at the moment, marketing and upselling, travel in all sorts of dynamic pricing. Healthcare is really exploding in healthcare at the moment with all of the sort of data trusts that are coming to surface. Sales is obviously, machine learning has been kind of in existence for a little while, and credit insurance, where it's a massively growing market but already quite big. So data science is spreading rapidly all through, and it's absolute kind of buzzword bingo at the moment, but it really is spreading like wildfire. Okay, so the difference between an analyst and a data scientist, and I think if I just come away from the slides for a moment and talk about my kind of interpretation of that, is that I think the distinction, and there is a big overlap, and I think that's part of the problem with answering that question, is people expect them to be totally distinct, and there is actually a large overlap if you're in this kind of exploratory data analysis section. But the predictive analytics is where data science really kind of sets itself apart. So I think this is the killer chart for me here. So if you've got your kind of pie charts of effort of analysis and data science, so the sort of descriptive analytics sits sort of equally within both of the sort of professions, and then the correlation, it mainly sticks with analysis, and the causation mainly sticks with the data science, sort of leaning towards the predictive causation in data science. So if you think of all your report writing and dashboard creation and data exploration with analysis, and then everything that comes from that with building your model, testing your model, then that's where, in my mind, that's where data science really sits. So I think I guess these four boxes aren't really representative of how much you spend your time. I think there's a massive amount of time, and this overlap is actually really big, because it might be one small section, but a massive amount of my time is spent cleaning, munging, understanding data, looking for this correlation, causation factors. So I think the whole industry, analysts, data scientists, engineers, is all becoming quite overlapped, and which is why there is this sort of confusion between the distinctions. Okay, so what do you need to know to start learning on your own? And this is a really, really simple question to answer. There are so many good resources out there. You don't need to know anything to start learning, okay? There's no like simple bit of snippet of information I can give you so that you can go and start that journey on your own. There are so many different resources which I'm going to talk you through where you can start this own journey. You don't feel put off. Whether you're really interested in this, you want to come to hackathons in your own spare time and become like an amateur data scientist, or you want to do it more professionally, there are no restrictions, especially with all of the resources that are out there at the moment. So I give a lot of these. I usually give one slide on useful resources, and I think I went away and reviewed my normal slide I give at this stage, and I thought, I don't really think I'm doing this justice. I think there's a lot more in this, as opposed to just saying, yeah, check out Udemy, check out Coursera, and obviously check out YouTube. I think actually I feel like I'm coming away from things like Udemy and Coursera. I think they're just flooded with so many different examples, and actually there are some better resources out there. So I still recommend things like Udemy, and I'm still really keep my eye on free codes for Python courses and stuff, and then I just enroll and then just leave them there if I ever want to look at them on a train or something. And if you follow my news feed, then if there's ever a free code, I always stick it on there for you, for the community to have a look at as well. So keep your eyes on that. So I think Udemy is useful, but it is, I think the whole market has just been absolutely swamped with material, and it's almost been overloaded. So I'm sort of leaning towards other material, which I'll get at in a minute. And then there's GitHub. Last time I think I gave this slide, I said GitHub is a useful resource to learn, but actually I think it is, but it can be quite overwhelming. And if you just look at somebody else's public GitHub page, you will probably be terrified, because there's a good chance that if they're already using GitHub and you're just starting out, they're going to be slightly more advanced than you. They're going to have something very complicated, and it will probably actually put you off. So be very careful. It's a great resource, but be very careful. And make sure, I think, so this isn't necessarily about a good resource, but in terms of a roadmap of how you learn, if you use Windows, and I think actually a lot of people now, I think, are starting to use Windows with data science, then you need to use something like Git Bash. And I remember years ago somebody saying, oh, you use Windows, how do you get on without using GitHub? Well, I guess you can use Git Bash. And I remember thinking, what on earth is Git Bash? And so I went away and did some reading, installed it, and learned how to use it. And it is a really useful thing. So if you don't know what I'm talking about at all with GitHub, so GitHub is public repositories, and GitLab is private. So if you want to keep your things private, you can use GitLab as well. And these things work automatically with Windows and Linux, so you can use them straight from the command line, but you can't do that in Windows. It doesn't work. You need to use some third party, kind of like a console, and Git Bash is the best one in my opinion. So if you use Windows, which probably, I see one Mac here, but I would fully recommend getting Git Bash and trying to understand how it works. So essentially the concept is you've got code in the cloud, and you can pull that code down, you can make changes to it, and then you can push that code up. And the idea is that you cannot break things. Okay, so if somebody else pulls it down and writes something stupid and they push it up, you can always revert the changes they've made. So you can code with people that don't know what they're doing so much. You can make different branches, so you can branch off the master and start doing some experimental things and then just get rid of it, or you can merge that if you like it with the master branch. So it's I think it's a really, really good place to start. So not so kind of going away from resources, but talking kind of your learning roadmap. Yeah, check out a video on how to use Git and get hold of Git Bash. It's a really, it is quite a steep learning curve, I'll be honest, but probably worth investing in, especially if you want to build an online presence, something that you can take and show somebody. Then if you've got a GitHub profile with all of your commits showing, when you're making changes to your code, then it's a really impressive thing. I don't use GitHub enough. I should use it more. I use it a lot when I'm doing interactive presentations and stuff, where I get everybody's code along. I get everybody to take the code from GitLab. And I think probably maybe in the next hack I'll do a masterclass on how to use Git. Might be quite a good idea. I don't think that's been done yet. Stack Overflow is actually a genuinely really useful resource. Because you can write your own questions, you get responses so fast. I know my colleague Matt is always using Stack Overflow. When I don't know how to do something, I say, Matt, how'd you do it? And he's got a question on there immediately. The one bit of advice I always give with Stack Overflow is be extremely precise with your questions. And if you write something really lazily and quickly as you're walking out the door, somebody will come back and complain and say, I don't know what you mean, this is not very precise. And then they can ban your account or they can suspend your account quite quickly. Because they don't want their whole platform filled up with people just writing really incoherent questions on there. I think that's fair enough. I have had one suspended once, and now I spend a little more time when I write them. YouTube. I'll be honest, if I don't know how to do something and I don't ask Matt, I will go to YouTube and watch a video. The biggest problem with YouTube is getting a little bit outdated for some of the content because the whole kind of sector is moving so quickly. It's really useful, especially people always link it to their GitHub account. I would say that is better than Udemy and better than Coursera at the moment. Just the only drawback being the fact that stuff is a little bit outdated. Okay, so masterclasses. Masterclasses are a great way of upskilling yourself. I think there are 4 or 5 masterclasses this weekend. We have other masterclasses through our meetup as well, Project Data Analytics, and there'll be lots of other masterclasses through the different parts of meetup as well. And hackathons, if you've never been to a hackathon, you should really go to one. They're really good. I'm sure you'd all really enjoy it. Yeah, they're a really good way to network. It's who you know is just as important as what you know. You never know when you meet somebody at these events in an offhand conversation, and it will lead to your next big break in your career. It really is important. This slide probably looks a little bit misleading. This is the masterclass I gave at the last hack, I think. One of the slides, and this is the tiny URL, so that's still live. I checked it. If you want to have the slide deck to that, and everything is in the slide deck, and I'm going to give you a quick walkthrough, then just navigate to tinyurl.com, and then just make a quick note of it, and it will auto download that pack, and then everything is in that, all the GitHub links, etc. So this is a video that I just put together a couple of days ago on the interactive. So I spent an hour going through this, and I'm about to do it in like 1 minute 50 seconds, so brace yourself. This is one slide from that deck that you'll get if you put that tiny URL link in. Okay, so you've just got the data there, which is saved in my GitHub. The GitHub URL where you've got that's my Python code that you can load into Google Colab. So Google Colab, if you haven't got Python and you haven't started, Google Colab is a really, really good place to start. You don't have to set up a complicated environment. You can just most people have a Google account, so you get this for free. Okay, you just open Google Colab, sign in with your Google credentials, and then you've got a fully functioning, with lots of packages already installed. You just literally just start coding in the browser. Nothing can go wrong. I think it is actually awesome, and so many people don't even know it exists. You're obviously not using any compute your side. It's all done server side, so you're not going to have big electricity bills because you can use an iPad and then run something in TensorFlow. It's really incredible that these kind of things exist. I'm sure there are equivalents as well with Microsoft, etc. But and for me, when I'm doing masterclasses like this, if everybody just brings their phone or their tablet or their PC, and I can just say load this link and then just code along with me. Everybody's actually running real code, but no one's had to go through the rigmarole of installing Python, setting your Python on your path, and all of the we'd spend 2 hours just troubleshooting, and then it would be quite awkward. So no, I went off track there. So that's Google Colab. So all you have to do is open Google Colab, take this GitHub link, and then paste it into Google Colab, download the data and load it in, save it on the server side, because obviously it needs to access the data to train the model, and then you're away. So I'm hoping this plays. So you just control click that, and it opens it in Excel. I just save it quickly as I think it's a CSV file. Rather stupidly, I called it the wrong name, so I called it data.csv, which was a bit dumb, and you'll see why in a minute. And like I said, you need this GitHub URL, so I click copy link, so that's now saved to the dashboard, and then I'm opening Google Colab. Remember, I'm already signed into Google, so I paste that GitHub link into the GitHub tab, press enter, and then it has a list of all the scripts in there that are in that repository. I just load the one that's of interest to me, and then it will load that script up. I've formatted it nicely for you with all these nice images, and everything, all the packages are all installed. You just have to click and play. It's really nice. All I'm doing here is loading up the data. So I called it data.csv, remember, and actually when I'm loading it in pandas, I want to, I've called it iris, so I just have to change that to data.csv. And then this is just me running through each line of the code. So this was a logistic regression model, so it's categorical data about the petal length and petal width and sepal length and sepal width, and given a new bit of data, what accuracy can we classify that particular species? So you can see there is quite a lot of correlation in the data already. So this walks you through the whole thing. Hopefully you should be able to follow this from top to bottom. The whole bit of analysis, it builds the model from scratch. It goes through test and train, so you split your data into your training set, so you train on this bit. Remember, it's all labeled, and then you test on your test data, and then obviously you're making predictions on data that already has labels, so you know what your accuracy is going to be. And you can see that with a very, very small data set, I think it's only got a couple of hundred rows in it, that we get 100% accuracy just from that small bit of data set. And that's because of you saw those plots, there was massive separation in the different flower species. So yeah, I'm not going to go into any more detail in that. I think I've already done it once. It's probably my masterclass is videoed somewhere, maybe. But obviously you've got the slide, so you can go through that in your own time as well. Does anyone have any questions for me so far? I feel like I'm going at 100 miles an hour, but is everybody digesting what I'm saying? I've lost you a bit. Where exactly did I lose you? This is a video, so it's not actually doing anything here, but this is Google Colab. So this is Python in the cloud. Python's a programming language. So what I'm doing is I'm connecting, so there's a loading machine somewhere, probably in Chicago or something, or maybe probably in India, that Google rent, and then I can tap into some of their compute, and they already have Python installed on them. So I'm connecting to them remotely from my machine, and then I wrote all of this, and then it's sending all of that information to them. They're computing it, and then they're sending all the output back. So what I was doing in that is this. So this is a predictive model that we built from scratch. So the first thing we did is load the data in, and then we do some exploratory sort of analysis on the data to see which bits of the data. So there were 4 inputs. The petal length and petal width and sepal length, sepal width. So we made some plots to see where the correlations were in that data. If we've got a really, really big petal width, for example, does that mean that it's probably Veronica, or that kind of thing? Where's the what? Sorry. I can try and find them. So I don't know if I can pause it from here. Maybe I can. Once I found out the correlations in the data, then I know which columns to train the model on. And then, so this shouldn't be too much about logistic regression, but the whole idea of logistic regression is it computes the coefficients for you in the logistic regression equation. So when you give it new data, it makes a prediction for you with a certain level of confidence. So I think I can pause it maybe. So the idea is that we're given a big chunk of data. If you imagine this is your chunk of data, and I chopped it 80-20, so I took 80% of the data and just fed it into my model and said train on this. So I'm not telling it explicitly what to do, I'm just saying train on those 4 things because they look like they have predictive behavior. Train on that. And then I take my 20%, which is still labeled data. So I still know, given those 4 parameters, which species of flower it is, and then I make predictions on those at 20%, and then compare the prediction with the actual, and then I can give my model an accuracy. Interesting, every time you run this, it comes out differently because I take all of the data and I randomly arrange it all. So it is different every single time. So you're training on a slightly different set of data, and then you get a slightly different. So it comes out about 100%. I think the lowest I've seen is 97 or something.
So is it predicted? It's saying I can predict what species the flower is from that data set?
Yeah, so given... Exactly, yeah. I mean, this is not that rigorous, and this is your kind of textbook machine learning example. This is where everybody starts. This is a really famous data set. The data's really lovely. You don't spend, usually if this is your problem, you spend this amount of time getting your data ready, and then what I've just shown you on screen is this. Luckily, the data's so perfect that that's actually, yeah.
Train it on these 4 bits of data because they looked as though they had predicted behaviour.
Yes.
How do you know?
So I was trying to stop it on the plots that we had there. So that was the analysis. You could see that the 3 different colours were the 3 different flower species, and you could see that they were very separated. So we were plotting I was plotting maybe petal length against petal width, and you could see that if those 2 bits of data were segmented, then there is, some predictive nature there, because given a new one, it's probably going to be in one of those clumps, and whichever clump it is,
you can tell which.
You could tell. So as a person, we could tell. It gets a bit more complicated if you had 1,000 variables, and I said there isn't predictive nature between these 2, but there is between 1,000. We would really struggle to do that. So it's a great example to tell a group of people that don't know much about machine learning what we mean by predictive nature, but it does get more confusing than it. Yeah, so I think if this is of interest to you, then this is all here for you just to go and play with. It should all work. I mean, check it out in the hackathon, and one of the team can come over and fix it for you if you can't get it to work, but it should be foolproof. So yeah, please play with it. Any more questions? Have I lost anyone else? Have you caught up? Good. Anyone else? Okay, so what's really important, and kind of going back to what I was saying earlier about it's easy to have a great, okay, it's not easy, but you can have a great CV and that won't necessarily get you the job you want. I think you need to have all of the extracurricular stuff. So it's about finding projects that you find interesting and working on them. And this isn't necessarily data science. So like I said in my introduction slide, where I'm really interested in tech and computers and servers and the internet, and I think if you start a project where, even if it's something really basic like one script that processes your download files and sorts your files for you, so it takes PDFs and puts them in a PDF folder, and it takes anything that has the word invoice in it and puts it in another folder for you and dates it for you, that's a really good place to start. It doesn't have to be something complicated like building your own cloud server with a Raspberry Pi. That's something to maybe to aim for in the future, but start with something simple. You could create your own first logistic regression model, because I've just created one for you. You can just download and start to play with. And you can start to find extra data sets, because I've only put a very small data set and load it into it, see what effect it has, see if you can find any other variables to load in and change it. So you've got a good foundation for building something complicated because of the resources that are out there already. Things like home security cameras, I'm in the process of trying to build one at the moment, so that the footage only is all stored in the cloud. It only activated when there's some sort of motion detection, things like that. So they're not all data science projects, but I feel like they all really contribute to your offering as a person, whether it's professionally or or not. And really, I think the whole thing is so connected with data engineering and technology that it's really useful to be involved in these kind of things. So one project I wanted to talk to you about in a little bit more detail is a slightly strange project that my brother came up with. So he was obsessed with Fortnite. My brother's a bit younger than me. And he wanted to get involved in data, and he's actually just got his first data engineering job 2 days ago. And I've been kind of helping him, maybe slightly coaching him through I think the 3-stage interview process, and he's just been successful, so he's done really well. But I told him to build a project around something he finds really interesting, and that happened to be Fortnite. And I'm sure there are things that do this already, and I'm sure someone who actually plays the game a lot would say, oh, somebody's already done that. But what we wanted to do is, try and do it again, even if we've done it quite badly, but that was fine. So he went and made screenshots of his game at the end. When you have this stats screen splashes up, and you just press screenshot on the Xbox. Don't know how you do that, but he did that. And I found out that it actually hosts those pictures online. So Microsoft push those pictures to a server somewhere, and they make those screenshots publicly available, which I thought was quite surprising, but do that. So together, we wrote a Python script. Maybe it was maybe 60-40 me doing it for him, really. Wrote a Python script to go to his public cloud storage area and grab those pictures, and literally just taking a copy of those pictures. So rather than we're having to somehow get them from the Xbox, we could just get them straight from the servers they've got there. And then we were applying, so we did that in Python. Okay, and then we wrote another script, and we used the Tesseract. So there's the Marvel reference. We used the Google Tesseract to process these images, because remember, they're just images. They don't have any, all of this data that was stored up here is not digitized in any way. So we did optical character recognition on that to turn that into data, and then we can build a dashboard from that. And I'll be brutally honest, he was really invested in this project, and then he got bored of it and stopped. So we didn't actually finish the dashboard, but we did do everything else. So we wrote the script to grab the images. So I'd say it was sort of 75% complete, this pipeline. The OCR worked really well with almost no errors at all, because the text was really consistently organized on screen. And we just needed to, so we were going to create a dashboard and look at his average accuracy and win-loss ratios and stuff like that. Obviously, it was dependent on him taking screenshots after each game, which is not ideal, but it certainly gave him an idea of how to pipeline data, how to code, and we went through. I think this bit's all quite fun, actually, and the analysis would have been an added bonus, which we never really got to. But that's the kind of thing which I think, although that's a bit stupid, and I think. Not the best example, it's a good example of taking something that somebody's really interested. I'm not. Probably very offensive, yeah. In a professional context, no, probably. It's not something it's not a slide I would show in front of clients, probably. But to connect data science and kind of engineering with something that somebody's really interested in and really invested in and really wants to improve, it's a good example. So this slide is about the languages you need to make progress with data science. So they're in a prioritized list, and the main thing to note really is that first of all, this is my opinion, so not necessarily the same as everyone else's, but you don't need all of the languages in here. So it depends on what you want to do. So things like MATLAB and maybe R are much more research-based, but languages like Python, they have a lot more flexibility, and they lead well onto things like TensorFlow as well. So ultimately, this Python RDA, I would recommend Python because of the flexibility. I think code is quite digestible. It's a really good place to start, but ultimately, I think we need to pick one and learn. I would say pick Python. So my methodology for data science is all kind of explained by this flowchart. So starting with a developer question, I think that is a really important place to start.
And we'll talk through that in more detail now. So in projecting success, we work with use cases and user stories. This is a very similar concept to develop your question. So the question is, what is your scientific goal? What are you trying to achieve? What would you do if you had all the data? And, ultimately, what are we trying to predict? We're doing predictive analytics. And if we want to find and ask these interesting questions. And then once we've got those questions, we need to find and get our data. So then we go through all the statistical processes, how's it sampled, what is relevant in the data, are there any privacy issues? So obviously we've got GDPR that might be a concern. And how do we best capture the data to solve the problems? Once we've done that,
4 different variables, and you think, if I compute this from this and add this onto this and combine it with this data set, and then before you know it, you've got like a spider web of stuff that is completely out of control. Start simply and up. Don't bite off more than you can chew at the beginning, because it's really, I think once you get involved in this, it can be kind of all-encompassing. Then you model your data, so you build your model. So we chose a logistic regression model. That was based on the type of data we had. So we had categorical data, which is really suitable for something like logistic regression. And it was already numerical, so we didn't even have to do any kind of dummy variable creation or anything like that. Okay, we built our model. We fit the model. And then we talked about the test train, so we saw how accurate the model was and validated it as well. Okay, and then once we've done that, we kind of go right back up to the top. So it's a 2-directional process. We came up with a question, we got the data that we could, and we did the analysis, and then we modeled it, but you will never have the right data, so you'll have to go back to the top, maybe refine your question. You might have to go down to the next level and capture different data. You might need to take weather data and bolt it on. This is where I start to contradict myself and start to make it overly complicated. But you have to really iterate. If I'm being totally honest, real world problems, like all the things that are being solved in there, the questions that we define will never have the right data for it. So this is when if you have that kind of feedback loop inside a company, for example, you might be able to change the way that data is collected so that you can actually solve the questions that are interesting to you. And I think it's really important to do it in this way. And at the moment, people see data as this pot of gold that we need to take the lid off and help ourselves to. And it isn't. That data could be completely useless. We shouldn't just collect it because we can. So I think it is ask the question, then try and get the data, and not the other way around. Okay, so like I said, you go back up to the top, you develop your question. I'm not going to go through the whole thing again, I'd be here all day. But, once you're happy with your kind of feedback loop and you think you've exhausted that, and you've made it sufficiently complicated, you communicate your results. So that might be a dashboard, that might be a report, that might be a presentation, whatever it might be. It might be a masterclass or a conference. Obviously, you need to put a lot of rigor into this. The model that I showed you earlier is not very rigorous, only very small data amounts. It was done as a proof of principle. So you need to make sure all your results make sense. And this can also be very, very time consuming as well. But is a lot easier if you've kept your model quite simple. So just before I finish, does anyone have any specific questions about my approach or methodology to these new problems? Anyone? Okay. Saw somebody going to take a picture, but You want to take a picture? Yeah, so I really believe, I mean, I've seen it time and time again where this is somebody's order to this is completely different, and the question is buried in the middle of it somewhere. I think going forward, if we really want to make transformational differences to industry, it's got to be like this, where we have the feedback loop to change the data collection. The other way around, we can't have transformation if we don't have the right data.
How do you determine the most kind of impactful type of exercise? So let's say someone comes to you with a problem. How do you compare it against a number of problems that could potentially be more important than how do you get to that point?
You mean how do you prioritise your...
Yeah, because there's so many questions you could do that are intrinsically interesting for interesting sake.
I think when it's a business problem, you look at your return on investment, so you work out how difficult it's going to be to solve it. And
how do you work that out?
I think that a lot of that comes from experience. You have a good feel for these things, and I think you can be relatively accurate with this, as long as, I don't think that's beyond the realms of possibility to put some kind of bound on it of how long it's going to take to solve it, and especially if you've got, say, 5 different projects in the pipeline. I think you can rank them and put vague times against them, and then calculate the return on investment. And that drives your priority list, really. If I'm doing it personally, then I just do whatever I want. Well, it was more interesting.
Do you find that you have, because there's so much to learn, do you find yourself with the tasks that are very deliverable and do this, and you use a very streamlined approach with only a few methods, and you're personal, I'm learning all these different ways I can do it?
I think it all blends together, actually. I don't think I segment it like that. I seem to find the things that I find interesting are things that I understand really well. So if I'm spending a lot of time doing something at work, I'll get curious, and then I'll look down and it's 10 o'clock at night and I should have stopped a long time ago. So that all sort of blends together, to be honest.
It's every single time, basically.
Yeah.
I'm fine with it.
So I think we've probably sort of moved on to the questions. That's everything I wanted to say. I hope that was useful. I saw people making some notes, so I hope it was good. If you want to ask me anything else, please feel free to do so.